So now that we've addressed the average rate of change, which is essentially slope, what we can now do is talk about a secant line. Now, what a secant line is, let's go here to the nice visualness that we have for the first one. We're talking about a line segment, and we kind of saw that. Let me put it in red. There's a line segment. Oops, sorry about that. That's not a very good line. But this line basically connects the two data points of interest, right? We got those data points based off of the interval. So given the interval that we're at, right, we're going to look at this point of interest for -3 and this point of interest for 4, and we can connect those 2 points of interest with a line. And so now that we have a line, this is called your secant line, by the way, when we do this. And now that we have a line, we should be able to find the equation for it. And so the data points that we have, one of the data points is -3, 3, and the other one is 4, -4. And what we can basically do to start finding this equation is we can begin by using the point slope form, because all I need is a slope, which we've got, and I need a point, which I have 2 of them. So I'm going to use that data point here. So plugging in what we know, right, here's x1 and y1, and there's my slope. We end up with y minus 3 equals -1, x minus a -3. And if we clean this up, this is y minus 3 equals, that's a -x plus 3. If you wanted to go that extra route here, we could add 3 to both sides, and we end up getting that y equals -x. So my graph's off, right? So y equals -x, that's basically the line, the secant line, that goes from point to point. So again, nice review of lines. The new concept of is a secant line. We developed that secant line by taking a look at the interval, looking at the 2 data points on the graph, and then connecting them with a line segment. Once I have that, we're back to 2.2 where we find the equation of a line. Here it is. This is the equation of the line, in point slope form, and there's what it would be in slope intercept if we solve for y. Same thing down here. I already kind of have a sketch of the situation, but one of my data points to find the equation of the tangent line for this, secant line, we basically take a look. One of my data points is -1, -2, right? So that's that data point there. And then the other data point was 3, 6, and that's that data point there. So now that I have 2 points, I can connect them with a line. So the question is, what's the equation of that line, which is the secant line? So again, I need the slope, but we already found it, right? That's sitting right there. And then I need an ordered pair. How about I use this one? So there's x1 and y1. So again, plugging this into my point slope form, we get y minus 6 equals 2x minus 3. And so this is y minus 6 equals 2x minus 6. And what we find is that y equals 2x. So that is the equation of that line that we have connected there. Alright, so again, the first thing before we can find the secant line is I actually need to find the slope. To find the slope, we use the average rate of change. Once I have the slope, I grab one of my points, put it in the point slope form, and if you want, you can put it in slope intercept form, which I also did as well. I think the textbook does that. So very much connected here with regard to these 2 ideas. The average rate of change is just the slope. What slope is it? It's the slope between the 2 points of interest over the interval that's given. Alright, and then once we have that, we have 2 points, we can find our equation of our secant line. So very, very important stuff, especially for those of you moving on to calculus. Alright, but for college algebra, hopefully you get the idea. Average rate of change gives you slope. It also gives you 2 data points. We can use those data points to find my secant line equation. One more concept, one more idea to cover, but I'll do that in a new video coming soon toward you.